right? Okay, hello. It seems like the resolutions of the video is a bit too low. Let's see. Let me try to fix this. If I can fix this. So it's the first time I use a software called OBS, and I'm not sure how I can fix this resolution issue. Yeah, that sounds weird. Let me see. Let's see if I can fix it. Otherwise, it's a bit hard to see what's going on here. Right. Okay, I guess I can see it on at least in full HD in my browser, in my other browser, so I'll just go with this. Okay. If anybody has some problem, let me know. Okay. So let's do this. It's a long time since I last did the tutorial live for Houdini. So this used to be a weekly tutorial live, which is not anymore, but I'll try to keep up with the pace. So this is a tutorial live for Houdini to show some algorithmic design process that I've been doing as a hobby or as a practice, and show some small or interesting tips along the way. And each week I have some topic to show. And today what I'd like to show is to implement a anisotropic, so-called anisotropic remeshing, which is to use some kind of vector field on the mesh to create the direction how the mesh is going to be remeshed. For example, what I'm using here is the principal curvature. Wait. So the volume is too low. Let me see. Okay. How's this? Maybe it's a bit too loud. Not sure. Sure, I mean, it sounds really loud in my environment. Okay. I'm hearing an echo. Okay. Maybe I should tweak some of the... Oh, okay, all right. Okay, then what was I? So I was trying to implement this anisotropic remeshing, which is to use the vector field on a mesh to take an account of the vector fields on a mesh together as size of the vector field. As a result, I could create a remeshing result, something like this. So this is based on the curvature, direction, and the amount. So if the amount is big, the curvature is big, when the bending amount is big, you have really skewed mesh triangle like these. If you have, and also based on the principal curvature direction. So as a result, you have some kind of interesting remeshing result like this. I heard this remeshing, anisotropic remeshing, could be useful for something like cloth simulations, if it can be done in dynamically or real time. But the way I'm have implemented might not be suitable for dynamic usage, because what I'm using here is vellum as one of the step. But rather than using like some difficult mathematical equations, trying to implement like linear algebra, I did it more graphical way to implement this one, so I think it's a bit more easier to understand what's going on here. And maybe if you have some knowledge on mathematics or linear algebra, you could probably transfer into an equation or own solver. So that's what I'd like to show, and as a result, you could use any sort of vector field, not just the curvature, but for example, a vector field from the tangent field, and as a result you could get something like this, which is currently based on the flow of the tangent field, or something like this, which is based on the gradient of the position in z direction, which could also be interesting. Not really sure how this could be useful for any of you, especially if you are in the entertainment field, but I thought the process itself could be really interesting, so it might be useful for some cases. I mean, the process itself could be useful for some cases, so I just wanted to share it with you. Right. So let's do this. Let's try to do this from scratch as always. And here's the new window. And let me know if you have any questions during the live. I don't have much information about the, I mean, I found there's one paper writing about the anisotropic remeshing. I think it's called adaptive anisotropic remeshing or something, but the method that I'm doing here is not really based on that. It's just a bit more brute force way using vellum, I mean physical simulations, so it might not be elegant at all, but could be fun to try out. So let's have some custom geometry or random geometry, anything is fine. I'm just gonna go with this one. Has it something to do with the intrinsic triangulation that Keen and Crane introduced in his paper? I am not sure. Intrinsic paper, I mean, it is related to modifying the triangles based on the direction, so it might be related, but I think I haven't seen that paper myself, so some part might be covered, some part might be the same, the idea itself, maybe. Okay, I'll check that out later. His method is always awesome, so wanted to dive in, but my mathematical knowledge is a bit too limited. I need to study more. Okay, so first thing first, the texture is not necessary, so I'm just going to get it out, hide the UV. Alright, and I'm gonna also triangulate this, because the method I'm gonna use has to use the triangulated geometry. So I'm gonna make this triangulated like this, and next I am going to calculate the normal direction for the point, which I'm going to use this for a vector field. Okay, so I'm just going to try the vector field, create a vector field out of curvature first as a initial test, which will create a what I would say beautiful remeshing, adaptive remeshing, anisotropic remeshing. So let's use a measure node to calculate the curvature, shall we? Right, and so what I'm going to calculate is the curvature, and I'm gonna do this per primitive, not per points, but rather primitive, and I'll explain later why. And I'm gonna calculate the curvature, and what I need is the direction and the amount, so I'm gonna choose the principal curvature. And I also don't need to have a curvature in negative values, so I'm gonna make it absolute, so that amount of the curvature will always be positive, which might not matter, but I'll do like this and make this vector. Okay, which will give you a direction and amount of the curvature. So where you have a steep curve, you have high curvature. If you have a flat surface, you have low curvature. Okay, and this will change the direction of the curvature. I'm not sure which one's better. I'm gonna try with the smaller one. So the remeshing that I would like to have is to have a triangle skewed in this direction in terms of the principal curvature. Well, currently it is already has some kind of effect like that, so maybe I'll make this pre-remeshed so that I could see the difference a bit better. Something like that, or well, I'm just gonna go with the original and see what happens. So what I would like to have is the triangulated mesh comes skewed on these high curvature with the direction, and not so much on the flat surface area, but still take an account of the principal direction, such as these or these or these. Okay. So after this, I am going to connect this to a null node. Maybe I should give the null node before calculating the curvature, because I would like to try many other field later. Right, so So after getting the principal curvature, what I would like to do now is, let's see. Try to connect this to switch so that I can choose from other vector field coming later. And let's try to change the name of the vector field. Currently it's called as curvature, but later I would like to use another field, so let's make it unified, like average field or ever field. Anything is fine. Okay, it's just a name. Now, next what I would like to do is to calculate the length, the amount of curvature for each vector values, just to see the histogram of the curvature. So I'm gonna use primitive wrangle. Let's name this field length. I'm gonna create an attribute called field length, just getting the value, the length of the curvature vector field. Right, let's check. Okay, so it's in between 0 to 0.3, right? So the maximum is 0.3. And what I would also like to note, so there's also 0 as well, which might be the position where the direction is, I mean the curvature is flat. The curvature 0 means flat. So you also have those, you also have these, and let's also get the minimum and the maximum of these attributes. Promote, attribute promote, from primitive to detail. I'm gonna get the minimum. First, get the minimum field length to detail. Okay. Actually, what I would like to get is the field length. So the 0 is the minimum. Let's get the maximum as well. Maximum. Rename it to maximum. Right. And then, so the maximum is 0.35 something. Right. Let's also get the median value to see if the histogram is on the center or a bit to the left or right. So get the median, rename this to mid. Okay, so I can see that the curvature histogram is a bit too shifted to the left because the median is pretty small, 0.02, and there's really high curvature, small number of high curvature. So it might be a good idea to trim these maximum value based on this median, so that this will come to the center to remap the whole amount of the curvature. I mean, it's not really necessary, but it might give you a better result. Let's just check. So I'm going to try to color each of the faces based on the curvature value, curvature amount, to see if it looks promising or has some gradient look. When I use the primitive wrangle, I'm gonna name this field length process, and first of all try to linearly remap the curvature between minimum to maximum and then change it to 0 to 1 and see how it is affecting each faces. So get the minimum. And the maximum. And remap the lengths with minimum field lengths, maximum field lengths, 2, 0, and 1. Alright. Now, so, and I am going to test this attributes by trying to use the color node. Primitive rem from attribute L. Okay, I don't see anything. Okay, I might be missing something. So this field length, do have it. Max field lengths, minimum field lengths, and let's see. The L value is okay. I do have L value. It seems like there's not much value above like 0.1 or 0.2. Most of the value is in between 0 to 0.1 or 2. So I guess that's the reason why I don't see much colors. Okay, so this is what it looks like right now. So if the color is white, or maybe change if the color is red, you have high curvature. If the color is blue, you have low curvature. And as I can see, not much high curvature. I mean, you could see some green values, but not so cleanly gradient. So what I'm gonna do is to clamp this curvature value to something a bit more clean to look at, to make these colors a bit more gradient based on the curvature. So in order to do that, I am going to modify the maximum or minimum based on the median. So get the median field lengths. And first of all, calculate. Let's assume that this is the middle value, okay? And so I want to go from, I want to see the difference between this one and this one, the medium and maximum, and medium and minimum. And if the difference is smaller, then I will pick that as a half of the range. So what I mean is the difference between max field lengths minus median field lengths, and I am going to compare this with the minimum and the minimum and the median field length differences. Compare it using min function so that I could get the smaller differences. Now this might give you a negative result in terms of this calculation, so I'm going to make it absolute just in case. Okay, now this will be the half amount of the range, the whole range. So the actual range that I want to use for this remap will be median field length minus diff and median field length plus diff. And now it would give you a bit more gradient result in terms of the curvature. Okay, I would like to give one more action to this, one more process to this value to see if I can have some different value. So try to use the power functions to see if I can modify these gradient. Okay, so this also give you some interesting result from 0 to 1 or 1 to 2. It might be okay with 1 for now. Right. Maybe. Maybe I could give another function like chramp to be able to control the remapping curve. Based on the curvature. Alright. Might be. But we'll try linearly first and see if we need to fix this later. But for now, I guess it looks okay. If we need a bit more smoothness, we could also apply some attribute blur, which I don't think I need it, but let's see. So make this as a, and I think I should do this before calculating the field lengths, so it's probably somewhere around here. Okay, I don't know if it's changing the thing. Oh, okay, I guess this only works for the points, not to the primitive. Alright. Yeah, so I guess this doesn't really work. Anyway, so in that case, let's just forget about it. And let's go. And what was I? So let's go with the setup. Might be okay. You have high curvature on the red part, small curvature on the green part, I mean the blue part. And you could control the range a bit more with these curve. Alright. Okay. Probably that's okay, and let's see. Let's go to the next step. So, before going into the actual implementation, I would like to show the whole process, the brief process that I would like to do. So, in order to do the anisotropic mesh, let's try with the other rabbit toy. Let me also delete the attributes. I'll just test out with the small example, a really simple example. So let's, and I'm going to use, so the normal remeshing, if you do the normal remeshing, like uniform remeshing, what you get is something like this. You have a rather regular shaped triangles all over the places, trying to remake these original mesh that you have. These. There's also an option to change it as adaptive, which will take in account the curvature. I guess the curvature is being taken account, and create the small triangles on the edges, on the creases, and the bigger triangles on the flat surface. But as you can see, the triangle shape is still uniform or regular shape. So what I'd like to do is to make these triangle shape skewed based on the direction, some input direction. And currently I don't think the original remesh node will be able to do that. So originally I wanted to make these triangles skewed on just in x direction or z direction. And to do that, that was much easier to do. Oh, hi, Master D and Necessary, thank you for the super chat. Appreciate it. So originally, in order to make these triangles skewed just on x or z direction, the step was easy. You just needed to use a transform node, scale it on y direction, something like 10, and do the remeshing when the scaling has been done, and scale back to the original shape by doing the inverse transformation. And as a result, you get these anisotropic triangle direction remeshing. So if it's just one way, or if it's just a planar remeshing, it's pretty easy. You just need to do the scaling, the uniform scaling. But what if I want to do this like parts by parts, place by places, based on like attributes on the surface? You cannot really use transform because this is just a uniform transforming, so scaling. You could do a uniform anisotropic remeshing like this, but not parts by parts. So the idea here is that idea I had initially in order to achieve the anisotropic remeshing per faces, based on any informations, could be a field, vector field or anything, is to, let me write it down. So if I have regular meshes, triangle meshes like these. So originally what I did using the transform node is to scale these to this direction, right? And then do the remeshing with this shape, creating some, creating the uniform, uniform triangles in this setup. Then scale this back to the original shape in terms of the boundary, which will give you kind of a skewed triangle in this direction. Okay, so that thing is really interesting. So if I could do these scaling part, this part, not just for the whole shape, but if I could do this for each of the shape using different direction, different amount of the scaling, then you might be able to create a skewed shape, a more controlled anisotropic reshaping. So that's my idea. So what the final process will be like is to try to wait. Let me duplicate this. Oops. I need these. So first of all, try to set the direction, in which direction you want to scale. Like for example, I want to scale this to this direction, this direction, this direction, this direction. Any direction is fine. And for each triangle, I am going to, why the color is changing constantly. Okay, so for each triangle, what I want to do is to scale these to that corresponding direction. So for this triangle, might be something like this. For this triangle, might be like that. For this triangle, like that, like that, like that, and like that. Okay, and then somehow connect each of the vertices together as the original structure. So there should be some connection between the vertices like that. And remesh this kind of unknown mesh stuff or unknown scaled geometry using this uniform remeshing, and would give something really weird shape. Not sure what it's gonna be like. And finally, somehow doing the inverse transformation and make this back to the original boundary shape, you might be getting the anisotropic remeshing at each part. Okay, so that's the goal. That's the concept of this process. That's the algorithm of this process. Now the big question is, how do we do each step? Let's say this is step 1, this is step 2, and this is step 3. So we have big 3 steps, and each time we need to do some kind of a process which is not available just using transform node. So in this case, we do need to use some kind of a vex or some other process. Now the main idea here is to, especially this one for step 1, the scaling for each triangle is easy. You just need to, I don't know, place each triangles on a 2D plane, maybe XY plane, and scale it in specific direction. That's easy. But the problem is, how do we connect those each triangle which has changed the shape together with one big structure as the original structure. To do that, I am introducing the spring-based physics simulations. So I'm creating a spring between the vertices, or in this case, I'm just going to share the edges, these edges together, and define the edge lengths of the shared edge, in this case this edge. And each time you calculate the size of triangles with the scale, you'll get the edge lengths for each triangles. So you get the edge lengths for this triangles, you have another edge length for this triangles, and since the scaling and the direction is different, you get different result between the shared edges. But I'm just going to make the average of these two edges and apply it as a goal edge length for the physics simulations. In this case, I'm going to use the cloth simulation constraints from Vellum and try to set the edge lengths of these shared triangle edges. Okay, so that might give you some interesting result, something like these. When you do the simulations, try to use the physics simulations to fit each edge length with the rest lengths that I have set customly based on these sizes. Now, after having these kind of in regular shape, I need to make this back to the original shape somehow. And that part is pretty easy to do actually. Thanks to Houdini's attribute structure, we could use an attribute called rest attribute, which will be preserved. We could use the rest attribute when the mesh has been created. So rest means the original point position. So even if the geometry has been meshed to some weird shape, you could still preserve this rest positions relatively. So after having the irregular mesh, I'm going to use the regular remeshing or uniform remeshing to this shape, which also preserve this rest. And rest of all, replacing each point position to its current rest position, which comes from this one. Somehow you'll be able to get the final result in original shape. Looks like an original shape. And I will show you briefly what it looks like in terms of how to make the shape back to the original using the rest. So let's say this is the original shape, and I'm going to use the node called rest, which will give you original point position as rest attributes, which is currently same point position. Right, now I could then randomly reshape this geometry. Maybe I can use something like mountain node to create some randomly wiggled shape. Make it really. After having irregular mesh like these, changing each edge length different, I'm going to do the remeshing using a uniform setup with some edge lengths, target edge lengths. Now after this, I can use something like point wrangle to, and if you look at the remeshed points, you still have these rest attributes, which comes from the original mesh, this one, which used to be a rubber toy. And now if I replace the current point position, which looks like this, with the rest position, you'll get original rubber toy silhouette, but changing the edge lengths to some custom or some random stuff, which comes from the mountain node. Right? So changing the mapping of these edge lengths, like doing this, and changing the mountain node offset. You still keep the boundary of the rubber toy, but changing the edge structures, I mean the lengths. So that's the step for the final. I hope it makes sense. So that's what I'm going to do. And so using random functions like mountain might be okay, noise functions like mountain might be okay to create a field, but I wanted to make it a bit more controllable, so that's why I'm calling this field based, so that I can control each triangle direction and the size altogether by using the vector field. Okay, I have a comment. All right, thank you for all the comments. Okay, so let's do this. Where was I? So I have calculated the curvature, I have the direction, and I have the field length, which is the size of the curvature at each primitive. So it's time to try to scale each triangle into these direction. Okay, so let's do that. But actually, let's go back to the, if you want to, let's say if you have a triangle like this, and if you want to skew it to this direction, you have to scale it this way, right? But then if the curvature, if you have a mesh like these, where you have a high curvature right here, the curvature flow might be in this direction. Okay. So, oh wait, what I mean, so if I wanted to, sorry, my mistake. Let's say I have this, I don't know, hexagonal shape, and want to make this skewed in X direction or Y direction like this. What I need to do is to, the direction itself, the direction of the skew or the anisotropy is this way. But the actual scaling that I have to do in order to achieve this is the other way, or the 90 degrees different. So this way. So I need, scale wise, I need to scale in this way, and as a result I could get the final result like this one. So the final result triangle direction and the scaling direction is perpendicular. Okay, so keep that in mind and let's try to implement that. Okay, so we need to do the scaling. And how do we do that? We could do this per primitive, but since we're going to use a vellum to preserve the structure to calculate the scaled mesh, partly scaled mesh, I'm just going to use the vellum cloth simulation or configure constraints, and just try to change this constraints for the stretch and change the rest lengths of these vellum constraints, so that will be more straightforward. Okay, so for the cloth I have both distance along edges, so I have stretch forces as well as bend forces. What I need to change these is the stretch, and let's also turn off the compression stiffness because we're not going to simulate the cloth itself, just want to keep the edge length the same at any cost. So in terms of that, we should not have this one. We don't need a realistic close outlook, but we need to always preserve the lengths with the rest lengths that we're gonna put. Okay, so that's probably it, and I'm going to use a primitive wrangle. So this is the key part of this tutorial, I guess. We need to change the edge lengths of these constraints based on the direction of the triangle scaling. So for each stretch, it should have one or two attached triangles. So these are the stretch edges, and if you look at the original shape, each edge always have some neighbor triangles, either one or two. If it's open shape, then it's one. If it's closed shape, it's two. So what we're going to do is for each edges, we're going to get two neighboring triangles and get these direction for both triangles. If you have two, if you only have one, just get one direction and the scale, and then use that to scale each triangle separately, and then calculate the middle edge distance or length for each triangle and get the average, and use that average to set it as a rest length of this edge. Okay, so that's the goal, and let's try to do this. Now, it might be hard to do without imagining what's going on here, so I think it's a good idea to test it with small set of datas. So what I am going to do is to just try to pick one item or specific item to try out the process. So what will be the better way to do that? Anyway, maybe it's a bit hard to do that way. I could do it per primitive or per faces or per edges, but in the end we need to do it per edges, so I'll just do it this way. Thing is, okay, so first thing first, we need to get a attached triangle for each edges. So for each edges, we should have a neighboring triangles, either one or two. So maybe I can just pick one edge and use it as a testing. Okay, so I'll just get the stretch and then get the first edge and using as a test geometry. So this is the edge, right, and the corresponding mesh, corresponding face is where it's a bit hard to see here. I think it's on the intersection, so let's choose another one, something a bit more easier to see. No, where is that? Okay, here we go. So we have these two triangles and we have these edge on the middle right here. So first thing what I would like to do is to get these primitive numbers to get the vector field from each faces, which is currently attached as a primitive attributes. So let's first get the point position from this line, stretch constraint lines. So prim points, and we know that the stretch constraints always have 2 points, so we could just say PT1 and PT2. Okay, now if you don't use these delete, then the point number itself will match with the geometry's point number. So I can just use these point number as it is, but if you are using delete somehow, which is not preferable, but some cases you might do. Then you have to find out the point number by yourself, the real point number of these mesh by yourself. So in those cases, I'm going to attach the shape to the second input and get the current point position of the edge vertices, the constraint vertices, and then using that I'm going to get the point number from the second input, because the point number on the first and the second is different because I'm using delete right now. So that's what I need to do now, which can be skipped if you don't use these delete, and which is a bit more preferable, because near point, by using near point you might get something different if it's too close. Okay, now it's time to get the primitive based on these two point informations. You can do that by creating half edge. So point edge. So I'm gonna create two half edge, assuming that I have at least one or two primitive triangles attached to this edge. Like that. Now I'm gonna check the primitive number belongs to each half edge. Okay, need to make this second input, and from half edge you can get the prim number. Now there is a chance that you get negative value -1 if you don't have a neighboring primitive in that direction. That happens if you are if the edge is at the border. In those cases you need to skip that. So if prim1 is more than 0, and if h prim2 is more than 0, you can calculate the lengths, or okay, I mean calculate the steps. Now but for here and for here, I want to scale the triangles of this primitive to a direction which is attached to this attribute, primitive's attributes. And I have to do this 2 times, at maximum 2 times, so maybe it's better to use for loop. Now I could create an array using these conditions. So let's create an array called prims, and if primitive exists, then I could add it to these attribute, I mean the array. Do the same for hprim2, and for each primitive let's do the loop. Okay, so far so good. Now the final value that I would like to calculate is the average lengths between 2 triangle edges. Okay, so that's the goal, and maybe we could also get the average direction as well as an optional value, the average of the vector field. Alright, so let's do this. inside the loop we could get primitive number, and then it's wrong. Okay, so for each primitive I could get several attributes. First I could get the vector field. Let's call this have a field prim1 field. Let me check if I really have these attributes from here. Looking at the primitive, so I have average field, it's the field, the directional field, as well as field lengths, and L is the one that I have used to remap the value. So in the end I could use these L value which was made here. Yeah, this one. Okay, so coming back to the code, let's get that L value as well. Prim L prim. Okay, now I think it's also a good idea to get the normal direction, because we want to scale this non-uniformly, meaning I just want to scale it to a specific direction. And to do that, I think it's good to have a normal direction of the faces. So let's calculate the normal of each face. Shall we place it? Where shall we place it? Here. Calculate the normal for the primitive and get that information as well. All right, getting good. Now I think I have enough information. It's time try to first of all assume that I have these triangle faces on 3D space, and I want to scale this in specific direction. Now how do we do that? In order to do that, we could use some rotation stuff. Now it's a bit hard to imagine by using the code for the edges, so I'm going to test it out using different primitive wrangle, and test it out with just one triangle and see if it's gonna work, and bring that function back to this one later. So just pick one triangle I can get from this one. Okay, so what I want to do is to get the field of this vector, the mesh, which is currently called as Ave field. So let's try to visualize it as a marker. Okay, it's a bit hard to see. Maybe the value is 0, close to 0. Let me see. Okay, so the one that I have chosen is 0. Okay, so let's use this one. Okay, so this one has some direction and the scale here. So this has a direction on this direction. I guess the reason why I have 0 is because the precision is a bit too low. Maybe I could change the precision for this curvature. Not sure, maybe not. Or before creating the curvature, I could create a the same name field for each primitive as a vector and make it as 64-bit, which will give you higher precisions, and that might give you a value. Well, I still have 0, so never mind about that. Just testing. Okay, so what I want to do here is scale these triangle to this direction. Or maybe not. This direction, I want to use this as a guide for the anisotropy. So actual scaling should go to perpendicular. Should be done in perpendicular direction. Okay, so in this case, the scale should done in this direction. So in order to do that, it's not straightforward. You need to first place this on 2D plane, XY or XZ plane, then scale it from that plane and rotate back to the original positions with the scaled result. So to do that, first you get all the point position from the triangle. So I have questions. Hi, Junichiro, I've been seeing. Good to see you all. Hello, small question. Vex stays the same through the different versions of they add some changes to it. Compared to the nodes, I think the change is pretty minimum. There are some additional variable introduced. Some variables has been introduced, like dictionary or something, or new functions. But most of the functions or type of the variable stays the same throughout the versions, I think. At least I'm using Houdini from version 15 and I don't see much difference in Vex. So other than adding a big dictionary type on 18 or something. So pretty much I think you could reuse the Vex for whole version, I think. In terms of the node changes a lot, so not so versatile over the version. Okay, so I have the big point position for each triangle. Okay, now what I want to do first is to move or rotate and transfer it to XY position or XZ position. Let's do this to XY position, shall we? Now, to do that, we need to use two directions. One is this field direction, one is the normal direction of this face. Having these two directions, I could project it onto the plane. So let's do that, and I'm going to use the function called dihedral, which will create a rotational matrix or quaternion which rotates from one direction to another direction. Okay. You could use either matrix 3 or vector 4. Vector 4 is the quaternion. I'll go with quaternion then. I guess either one is fine to use. Quaternion is more rotate oriented, matrix 3 can be used for other purposes as well sometimes. And vector 4 as well, but most of the time quaternion used for rotation, I think, from my understanding. So the field name is avid field, and I want to rotate the average field, which is this one, to, let's say, x direction. Okay. Now, using this quaternion, I want to rotate each of these points so that it will align to x direction. But I will need to do this one more time, because if it's just one axis, you still have some rotation on this axis. So you need to use this normal direction as well to map to do another rotation. So I'm going to create one more quaternion which rotates the normal direction to 0, 0, 1. Okay. Now, but thing is that this normal should also be rotated using this quaternion before using another rotation, because the rotation has to be chained. So I'm going to update the rotation of the normal direction by rotating it using quaternion 1, using qRotate function like this, and then the normal will be updated. You can use it for the second rotation. Okay. Now that you have two quaternion, it's time for you to rotate the point position as well. Right. So to do that, first I'm going to move this to the center of the primitive. I mean, subdivide by center of the primitive, which is the centroid of the triangle, just to make sure that it's going to be rotated on the origin, which might be easier to see. And then do the first rotation using qRotate, using quaternion 1, do another rotation, quaternion 2, and let's see what happens. I am going to set point attribute, update the point position of each triangle with this position, see what happens. Now, as you can see, okay, I have some problem here. It's not really okay. The problem is the field that I have right now is not really aligned with the triangle shape itself. So what I needed to do is to first align this field so that it's on top of the triangle mesh. Now we could do that previously where we have this curvatures field, which looks like it is being aligned, but maybe at some point it's not anymore. Not sure. It does look like it's being aligned. Let me see where that was. Oh well, it is actually aligned. So okay, so that's because I have rotated. So that's why I am not getting the right aligned direction. Now let's see what was wrong here. So I have rotated with this first quaternion, which is using average field. Right, this one. Let's check that by try not to use the second quaternion. See what happens. Okay, so this one seems to be okay. Let's also rotate this average field with this quaternion. So Q rotate quat 1 and update the average field with this one. Oops. Well, anyway, the direction seems correct. So that's fine. Now we have the second rotation, which is using the normal direction, and this part seems to do some problem here. So oops, so I have the second rotation. I have first rotated the normal direction, which looks okay. This is the updated normal direction. Then I have quaternion 2, which is using the current normal direction to z direction. Okay. Then using that quaternion to rotate the point position with these. So, and I was hoping this to be flat. It's not really flat, is it? Not sure why. Let me try with matrix 3, see if I get the same result. Okay. Yeah, same result. So, not sure why. Let me try to rotate in different order. So I have vector 4, quad 2, which comes first, right? Then I am rotating the average field instead of a normal. Okay, and then use that to create another rotation, and then skip this part. Okay, so this seems to do better result. This is now on XY plane. Not sure why it didn't work with the previous setup. Not sure. But now I could see, okay, I would also like to rotate the average field again with Q rotate using quad 1. Oops. Now the direction is on X direction, looks good. And for the normal, it's on the perpendicular direction, and that also seems fine, which I didn't really rotate. Maybe the normal itself is being updated automatically. That's the reason why it didn't really work last time. Maybe that's the case. So I guess it's better to get the normal outside as a variable. And because using the normal direction directly from the attribute might give you some weird result. That's what I assumed. Maybe not. Let's do this outside the loop and use that. Well, still get these. Wait, originally the normal direction is this one, right? Now I still have this normal direction, but it still shows the direction to this direction. Why is that? Shouldn't point to this direction. Let me reset the viewport. Not sure why. Wait, sorry, I shouldn't update the normal to the point, but I should. Okay, now I know why. The reason why it didn't work last time because I was using for loop, and each for loop I was changing this normal again and again. That was the reason why it didn't work last time. Okay, makes sense. So everything looks okay. Now it's time to do the scaling. Now since this average field direction is the anisotropic direction, the scaling direction is actually perpendicular to this one, so it's y direction. So we could do the scaling here. So we can change this y value to something like 10 to do the scaling, and then we could make this back to the original position by do the inverse rotation by creating the inversed quaternion. I quat 1 is q invert right. Then goes from use that to rotate back to the position in the reverse order. And finally we could add the centroid. Now let's move to this wall, this direction, and let's change. Let's see what happened from the original shape to the scaled shape. Okay, as you can see, this is the field direction and this is the perpendicular of the direction, and it is being scaled to the perpendicular direction by doing like this. And you could change the scale value here to change the scale based on the direction. Now we want to change this scale value based on the L value, which is attached to the attribute, attached as an attribute, this one, which is from 0 to 1. So we could now change this to fit 0, 1 FL to, I don't know, from 1 to 10, something like that. So based on the value you could change the scale. Maybe this could be parameterized. Now this is for the one triangle. Let's see if this is gonna work for all the triangles. And we could test that by making all the triangles unique. Just use the unique points to detach all the vertices. And this is the result. So for each triangle, it has its own direction and value, changing the scale based on those information. Okay, so as you can see, this is a really looks like it's really messed up, but the goal is to apply this transformation to all the triangles, and at the same time each vertex is still attached to the neighbor triangles. Okay, which is a bit hard to do mathematically or geometrically using like linear algebra, so that's why I'm using Vellum to solve this non-linear problem, right? All right. So that's the test, and we could reuse these to do the scaling. So I'm gonna just copy these, bring it back to this one line code. Now, where can we use that? Let's just paste it right here. And since we have two primitives, we could bring all these code inside the for loop. Like that. Okay, let's open up the code editor. Guess I should use the external code editor like Sublime or something, which I haven't set it up. Okay, now let's see what I need to change. So first I need to get the normal, which I already have it, so let's remove this. And I was getting all the points from the primitive, but currently all the points I need is just these 2 points, because I just need those edge information. I don't need to calculate the rotation and scaling for all the 3 points from the triangles. I just need to do that for these 2 points. So let's just so instead of having this one, you could have an array by yourself. Something like that. So you have 2 points. All right. Now all rest of the stuff could be reusable pretty much. I just need to change some of the stuff. First of all, I am creating the quaternion, going from the normal to z direction, that's fine. And I'm rotating the average field. Now this part, need to change it to this one right here. Okay. Now second quaternion, rotating the average field. Okay, I might need to rename this so that I could only use this inside this loop. Just like the problem I had last time, it's better to create the unique name inside this loop. Okay. In terms of the normal, I'm not changing anything here, so I think I could just keep it as it is. And so I have these. Now this also needs to be changed. I'm not working on the point position or primitive. Wait. Primitive wrangle. I need to get the centroid of the triangles from this primitive, so let's just get that refuge. Anyway, I don't think I don't really need to offset it to the center, because I just need to do the rotation and scaling, make this back to the original position. So I guess I don't need to do this process, but just in case. Okay, now finally this one, FL has to be changed with this value here. Okay, and this part, the scaling part, could be changed. So the minimum could be 1, or could also go smaller, but let's say I will keep the minimum. Well, it's just made it possible to change both scaling. Like that. Okay. And X and Z is scaled to 1. That's fine. And I don't need to update the point position. I just need to calculate the edge lengths, the updated edge lengths. Okay. So this function for 2 points will update the triangle edge position. Okay. And using the final point position, I can get the distance between this one and this one, updated edge position, and for each primitive, if I have 2 primitive, then I could get 2 different edge lengths. And finally, I want to get the average of those 2 edges. So the way to do that, going to create the array of vectors. Yes, there's many ways, but for each loop I'm going to append this position that I have calculated here. Then outside the loop, I know that I always have 2 positions because of these loop. I'm going to calculate the edge lengths, calculating the distance between positions, calculating the positions 1 minus positions 0. Alright, now I'm gonna add it to the average lengths attribute variable outside the loop. And if you have 2 primitives, then you get the average by dividing by the lengths of prims. Okay. Oops, errors. Distance. Okay, I should not subtract it. Okay, so let's see. So now I should be able to get the average lengths using these code for each edges. It's time to use this to update the rest lengths, which is going to be used as a constraint value. Okay, goal lengths for the spring force. I guess that's pretty much it. And let's check that out. Now, I also have additional vector value that I could use. So let's try to have that as well. Which could be this, which could be just adding these average field here, and could also be normalized, I guess. Not sure if I should normalize or not, but do the divisions like I did for the average lengths. Okay, let's check if I have this rest length apply. Oops, nope, 0. Something must be wrong. Average direction is also 0. Okay. Okay, I did something wrong then, for sure. So, okay, I do have average direction. So I am getting these value. What's this? Decoration of PTS. Oh, I think I'm reusing the name right here. I should use the different name here. Let's call this NPTS. NPTS. And okay, I'm reusing this I value as well. Okay, that's not okay. How's that? Okay, do I get the update? Okay, now I get this rest length, and originally it was 0.04, so it got shorter. Okay, so hopefully that is correct. I'm not sure. Can't really see it from these just edges, so let's try to get rid of this delete and try to see it here, and if I can see all the updates for each edges. So so this is the updated rest length. This used to be the original rest length. The value sometimes changes, sometimes not. Makes sense. If the curvature is 0, it shouldn't change. Alright, so let's also remove this one and connect this here, and let's bring up the vellum solver. Okay, connect this one here. No, not here. Here, and this one to here. Okay, I don't have to do anything inside the solver, I think. And let's see, I don't need the collision, so I'm just gonna disable it, which will make the simulation faster. That's good. I don't need the wind, I don't need the gravity. Just need to make the edge lengths to what I have set. That's all I need. And I do need some bendings to make a smooth result. So let's make the bending a bit more stronger. Not sure how much, maybe 1. Okay, let's see. Let's see what happens with this setup. Hopefully it's not gonna explode. Okay. So as a result, you get something like these, which doesn't really look nice at all. But as I said, it's supposed to look like this. It's supposed to look really irregular shape. What we need to do here after this is to do the uniform remeshing using these mesh. So do the remeshing after changing the edge lengths. So let's see, using 0.01. Okay, and then we're going to make this back to the original position using the rest position, but I have realized I didn't put any rest node anywhere, so I should do that somewhere. Let's do this here, meaning I have to redo the simulation. Okay, let's redo the simulation. And well, the color is a bit too much, so I'm gonna get rid of the color, make it white. Or maybe random is fine. Okay, and then make the uniform remesh. I'll just go with just one constant color for now. Okay, now time to make this back to the original shape. That, and as a result, okay, I do see some stuff here. So based on the curvature and the direction, I think something is happening here or here. Especially these part looks really obvious. Let's see what the field looks like. So if I look at the field, currently the field, these fields are in this direction, these fields are in this direction. Although I don't see much directionality in this direction, but I see directions in this way. So not so much, not so correct, I guess. So let me try to change the value of the principal curvature to something different. Maybe I need to use an absolute larger, which will give you a bit more information about the size of the curvature. Now, as I can see now, the mapping of the curvature looks a bit more sophisticated. Okay, just a little bit more sophisticated. And the direction wise, it's a bit too loud. Let me change this to just scale to here. So the flow is coming like these, like that. So if we do have a clean flow rather than the smaller one, we do have some big curvatures on these areas. But I can see that the direction has to be rotated 90 degrees, especially for these areas. It's going this way. But in order to have anisotropic meshing in this way, I want to rotate it 90 degrees. So let's do that only for these curvatures. To do that, I need to calculate the normal direction of the face. Then do the rotation 90 degrees along these normal as an axis. Degrees with the normal direction, and rotate it with the matrix. Alright, that looks better. Looks much like it. Okay, now let's try to redo the simulations again. See what happens. It's simulation part looks really funny, but this actually works. Remeshing and make it back. Okay, obviously the direction is wrong, especially these areas. I am not sure which part I did wrong. Let me check that by going back to this constraints. Check each edges, maybe by coloring it. So based on the average length or rest lengths, I'm going to try to color it. So primitive, run from attribute, rest length, and let's also check the range. This length is from 0 to 0.09. Okay, so we have these. Okay, obviously it's scaling to the other direction because this one doesn't really scale because it's stayed as 1. In this direction it's scaling a lot, and also need to check if the L is in between 0 to 1. That, yeah, that seems like so. Okay. Also need to check. Let me also check the curvature direction. Okay, so considering this is this direction, and currently it's scaling with this direction somehow. Why is that? Why is that? I'm guessing something could be wrong. First of all, let me check again with these. If it's scaling to the oh well, yeah, for this one it's scaling to the right direction. So if you have a field like this, it's supposed to scale in this direction, and it does seem like seems like it's scaling to that direction. So this, the original implementation looks correct. Now the problem here is I was wondering if this is doing something wrong. I need to check. So I have this point position, which doesn't really matter. The normal average field from the second input. Do I have that? Oh yeah, I do. Should be the same as this one. Yeah, that's fine. And so rotating, I am rotating this position. Oh, wait a minute, what's this? Okay, this is obviously wrong. Or is it? No, yeah, it is wrong. Has to get from the second input. But if I get rid of this delete, it's not a big problem anymore. So maybe not, this is not the part which has the problem. And I have quaternion, average field, quaternion again, rotating the average field. Yeah. Oh wait, I didn't set the scale. That's why. Okay. Now, my bad. Let's say if you have smaller curvature, make the scale to 1. If you have a bigger curvature, make it 10 scale. Okay. Now obviously that was the place I needed to fix, I think. Let's see again. Do the mesh. Okay. Full. And do the remeshing. Maybe this is too big. I also wanted to make possible so that this could be a bit more controllable, because we don't really know what's the best value for this target size. Okay, now obviously this is too big. Okay, make this back and recalculate the normal, see what happens. There you go. Better result. So the mesh is aligned with the curvature. Mesh has been anisotropically remeshed using the vector field like this. Now it's not really clean from what I see, so let's see how we could fix that. First of all, we could try to change the iteration, since I don't want to like play this timeline each time I need to check, so I'm going to change the setup of this vellum so that I don't need to use the timeline to calculate the steps. So instead of using the dynamic approach, I am going to go to the simulation tab, change this to quasi-static so that I can set the calculation steps previously so that they will be calculated in single step. This is useful. So let's say I just need to calculate 20 steps. Right. Now let's see what else I could do here. So first of all, let's try to change the bending strength something high. See if we could give some differences. Nope, not much. If I change the scale value to 1 and 1, which will obviously won't scale to any direction, so it doesn't really gonna change anything. If I make this to 1, 5, starts to take account of the curvature direction. Yeah. 110 gives some more obvious changes. Now it could also depend on the original shape of the geometry, I think. So if we do additional remeshing beforehand somehow, somewhere like this, might also change the result. like that. Okay. So after this you could try, this is the whole setup, the base setup. I think after this you could try to tweak this a little bit more, fine tune the setup a bit more. Right now I don't really like this stuff like here. Maybe I could do more of these. Now in order to do that, in order to achieve that, I think it's due to the smoothness of the simulation. So let's see if I could do something for the setup of the simulation. Gotta remember what I did, but it's pretty much the same. I mean, I don't need gravity, I don't need collisions. So what about the cloth? So in terms of the stretch, yeah, I don't think I need the compression. For the bending, maybe I could increase the bending really high. See if I can see the change. Not much. I don't see changes, not much. Well, it is doing what it does, but you could do more. Let's see if I subdivide it and see if I get any differences. Okay, well, I needed to calculate the curvature, so I need to place this above, somewhere around here. Okay, not so good, is it? Does it have quadrilateral? So calculating here, calculating curvature. Let me see. So I'm calculating the larger absolute curvature. It's an average field, rotating it. Okay. And remapping the lengths like that. Okay. And maybe I could make it a bit more smoother, like this way. See what happens. This part. So what's happening with this part? So it's not really scaling much here. Okay. So let's see what else I could do here. Let me also go back to the original stuff that I made and see if I did something different. Oh, I don't think I did. Okay, I guess the problem is when the scale is equal to 0 right here. Maybe I'm getting the value other than 1 between 10 here. This one here. So let's check what kind of value I'm getting here. Okay, so where shall we get that? Where shall we? Gonna make this as variable. And try to get that value for each edges. Check that value. If I get less than 1, then that should be the problem. Okay, so okay, I don't think I see less than 1. Everything looks fine. That's not a problem, I guess. That shouldn't be a problem. I think. That's fine. So what else did I do here? Okay, instead of using near points, just gonna try to use this point number as it is, because it's more stable. Right, what else? Yeah, let's see. And but I could see that it is taking an account of these original curvature, so I guess you could call these correct. Just want to know if I can make it a bit more smoother. Especially these part looks a bit too much. What if I use this one? No, not much difference. Let me check this out using a pig head. See if I can see different result, because I was testing with the pig head and that was giving me a bit more smoother result. If this one doesn't give, okay, this one does give a better result. So I guess I need to do some tweaking for the meshes, like rubber toy. Yes, this one looks a bit better. Maybe the scaling is a bit too high. Oops. And I need to also control these. Yep. Change this to rubber toy. Wow. guess that's due to the differences between the curvature values. And in order to fix that, not sure what's the best way. Wait. I guess it's due to the remapping process, especially where I did these. Right. So instead of using that, what happens if I just remap the field? Then just use the minimum and the maximum as it is as a range. Which will have, okay, now what I have a problem that a lot of the values are in this range, and just partial of the values right here, so can't really see the difference between the values if I just use the linear mapping. Now that's obviously not good, so I guess keeping this is still fine. To have the gradual changes. Alright. Now, why am I having some big value here? So where you have blue parts, you have less scales. Where you have red part, you have larger scales. So I guess if I increase this minimum value as well, bit better result. If you make it the same, you have similar to using the uniformed or normalized vector field. Okay. And yeah. So guess it's getting there. Still there are some stuff I don't really like about it, but let's try to give another kind of vector field, like using gradient. A gradient. Based on, I don't know, z direction. Change it to the gradient and name it to the same name, average field. See what happens. Okay, and would like to give the size 10 as a maximum. Mesh size is a bit too big. Okay, so it's creating a direction in this way. The grading itself, if I short it up, so you have these z direction to on a mesh like that, and it will use that information to do the anisotropic remeshing like that. So I think it's correct. Yeah, and if the value is small, you don't have much scaling. If the value is large, you have more scaling. Looks funny. Maybe the scaling is a bit too much. Now, due to using the vellum solver, the size depends. The size really changes a lot when doing the simulations, and when using the uniform remeshing to the result of the simulations, you need to take an account of how much it rescaled from the original shape. So let's compare the area between the original mesh and the simulated mesh, then use the scale to make the final mesh area size similar to what we have as original. So calculate the total area of the original mesh, and also calculate the mesh of the simulated one. And based on those information, I'm going to do the transformation, or let's just use point wrangle to do that. So the source area and target area. We need to create a scale, how much we should scale the target so that it will come close to the source area. And the area is being calculated by the power of 2 measurement unit. So I'm going to calculate the square root of target area, and also calculate the square root of source area and divide it by target area, and that will be the actual scaling. And I'm going to multiply point position with the SC so that the final total area of this thing should be equal to the source 1. So currently the total area of the target is 8, and this one is also 8, so it's the same area. Now, by using this, you could use a bit more constant value for the remeshing. This one. Maybe I could also use some iterations for this one. Right. Okay, what's happened? What happened? Maybe I shouldn't do the smoothing. Yeah, smoothing doesn't give you a better result, I guess. Just a little bit is fine. Seems like it is also changing the rest. Still rest. precision. Okay. Right. So if I make scaling to 0.4, since these are all separated, maybe I need to give a considerations to each parts, each islands. But for now, yeah, this will give a really big face here. I guess this area is not getting any scales. Yeah, not much scaling happening here. I guess that's why. What about the pig head? So pig head is getting a bit better result. Somehow this one not so much. Maybe it's due to the number of islands, I'm not sure. Let me just pick one of the parts, see if I only have that, see if I'm gonna get any changes. Not so much. Now it looks like a duck. I want to know how I could make this a bit more better result. If I initially remesh this, do I get any better result? Okay, now it's gone. Where did it go? Ooh. Ooh. What happened? Oh, wow. Okay, so it's obviously it's exploding somehow. So something must have been wrong. Maybe it's due to the structure of the mesh. Maybe the one edge is having more than 2 primitive. That's the case. That might happen. Oh, wow. No, oh wait. It's already losing the mesh right here. Where did we lose that? Where? What? Oh. Okay. Well, I guess this is correct. I mean, not so, doesn't look good, but not so wrong. If I make this curve, tweak this curve, maybe I get some better result based on these curvature values. So having 0 might not always a good idea. So I need to think about the balance between the minimum scale and the maximum scale. Interesting. Let's go with the curvature. So, and I am wondering, having these results, I'm wondering if the stuff that I wrote here is really correct or not. So it's kind of a cheat, but I'm going to bring the one that I wrote before and check. Oh, reading commercial session mode. I think it's okay because I'm using the indie, right? Right. And see if this one gives different result. Okay, this implementation wise, I think this is a bit different. In terms of, especially in terms of the scaling part, it looks different. Yeah. So instead of using okay, I want to scale in Y direction. Nothing happened. Where does this L come from? Length average field. Ah, okay. So it's getting the length of the average field, which I guess I have modified it previously. But this one looks cleaner. Let me just look at the previous one, see what it looks like with the Rabbitoy. See if I'm getting this similar result. Nope. I think this one looks much better. Yup. So I think I am doing something wrong here. Yeah, this one looks much better in terms of the remeshing. So I need to check what I did wrong. Well, I know that the scaling part, I think I did different stuff in the scaling part, especially like here. So let's see how I made the scales previously. Can't remember. So previously these parts are pretty much the same, but now the difference is that after I did the remap, wait, did I do that? Did I do that? Okay, so I do have median field lengths, Okay, let's check if I'm really getting that value. This is more like a debug. Okay, I'm getting that. Maximum. Yep. Minimum. Okay. Oh. Yeah. Okay, so if that's fine, max, min, max and median and a minimum, it's fine. Getting the minimum from median minus different to median plus different also looks correct. And probably I don't wait. Yeah, this doesn't really do anything right now. This is pretty much the straight line, which also doesn't really do anything here. Now on the previous setup I was calculating the scale at this point somehow. Right. Which is pretty much the same. Okay, so and what I'm doing here is updating the average field size as well. So let's try to do that. And instead of scaling, having this minimum and maximum scale like here, let's just do that previously. Instead of having the scale here, just use the lengths of average field, just this one, and don't use this one. Okay, now let's go back and give fit function to update it, the scale right here. Scale from 1 to 10. Okay, what's wrong with this? Oops, need to close this here. Oh, I have a comment from Otnian. Actually, there's a paper on field-based anisotropic remeshing by Caltech. Ah, really? They actually give pretty great example how to do this stuff. That's good to know. I need to check that out. Yes, I'll do that later. Now, after this, what was I trying to do? So I have the updated lengths. What I want to do now is to update the average field with normalized average field multiplied by L. And well, I could also give L as an attribute as well. Alright. And maybe I could also give another attribute call just to colorize the value here, and use this to color attribute. Okay, and also let's check the vector value. Okay, so it looks like this. Now after doing the simulations, what does it look like? Okay, it's looks pretty much the same, I guess. Comparing to this one, let me just use the same value, 1, 2, 10. Okay, seems like I do also have the color here, ramp here. So let's also remove the ramp. Well, I still get better result. What's so different? Let me say. So the length is in between 1 to 10. Should be the same for this one. Yeah, 1 to 10. Pretty much the same. Field length is between 0 to 11. Now that one is a bit different. So I was using curvature principle. Same. Yeah. Right. So in terms of the curvature value, curvature maximum and minimum looks a bit different somehow. You have 0 to 11. But the color map wise looks pretty much the same, I think. Maybe a bit different. Why? Am I really using the median? Yeah, median field length. Well, original curvature map looks a bit different somehow. And I am not sure why. Maximum is 11. Okay, so it looks like these. Yeah, pretty much the same, I think. Wait, I'm using the remeshed version. So this way should be the same result, it should give you the same result. But the final result looks totally different somehow. Why is that? Okay, so the color map wise looks the same. So other than that, I gotta assume that the edge calculation part must be wrong, I guess, which is here. So this part, maybe I did something wrong here. So let me check. Okay. So just moving this to the left. Okay, getting the points, getting the edge, half edge, primitives. Yeah, this is also the same. Checking if there's second stuff, and I'm also initializing average lengths. Getting a center, which doesn't exist here, but that's fine. Wait a minute. Oh yeah, it's fine. And I have this array here, which is similar to these. And this is the direction of the average field, and it's rotating 90 degrees based on the normal direction, which is in order to use the scale for x-axis. So that's not really important. Okay. Do the rotation 2 times, which is pretty much the same. Right. And getting the vector positions, it's pretty much the same. And do the loop. Doing the loop 2 times for each point. Should I change the name here? Nope. Getting the position. Well, this could be 0, but doesn't really need to. Doesn't give much changes. And after getting all the informations, it says I'm using @p, so let's see if it does anything. I don't think it does. Oh, it did change something. Wait, really? Do I really need that? Do I really need this? Yeah, I guess it does give a lot of changes. So @p means the center of edges. But why does it change stuff? Not sure. So okay, rotating position, rotating, and scaling with the average length of the average field, which is similar to here, which is the length of average field, right? What if I change to the same setup here? Okay, so having L and direction outside. And use L here. Oh. Gives an error. Why is that? Oh, okay. So I don't have the normal here. Okay, now it gives a more weird result. Is this giving me the right normal direction? Yup, I think so. Okay. And the average field, am I really getting that? Hopefully. And obviously the scaling direction is not correct, so that's because I'm using different rotational orders, so I think I need to use this L somewhere different, either Y or Z. I guess Y was correct, but in those cases, same setup as I did without rotating the... Oh, okay, I'm not using direction anywhere. So, to use this direction, oh well, let's just replace this with the original. So I have these. Let's get this. Wait. Maybe I know what I did wrong. Okay, calculating those quaternions. Seems like I'm calculating quaternion inside here. That might have been a problem. Right. Now. Now I have rot 1, rot 2, rotating with rot 1, rot 2, and I rot 2 and 1. And change the scale with L 1 1 and the normal also need to get that normal direction. Just rename this to N. Wait, to use then here. Okay. And other than that, it's pretty much the same. Calculating the distance, adding average lengths here. Oh, Do I need to make it float? I don't know. Since this is already float, I don't think I need to, but okay, I think I'm just getting the same result as before. Not sure why. Not sure why I'm getting this different result. This one obviously looks much cleaner. Doesn't have too much skilled stuff here. Even if I change the scale to 1 to 100, still give you better result. Otherwise, but for this case, if I give 1 to 100, I think it's gonna just make meshes really dirty. Why? I'm changing rest lengths. Yeah. Rest ranks. Wait a minute. Why am I? I shouldn't have delete. This is removing the bending. I guess that's shoot. Okay, big mistake. Okay, that was it, I think. Much better. So the reason was I was using this delete, which I only used it for the debugging but forgot to remove it. So I guess the previous implementation was correct, just that these delete was removing the bending forces which prevent this being smooth. Okay. Oh, sorry for that. I guess, but in the end it went well. Let me just clean this up. Okay, so, well, that's what happens if I try to do this on live. Anyway, I think it went all well. If I color this randomly. Yeah, I could see the flow. I do see a small stuff here, but that might changing the step of the simulations, like 25 or something. Yep. Much better. Okay. So, changing this to a gradient. Yup, much better. Much better. Clean flow. rather clean mesh. I do have some bends here, but overall looks fine. I think it is taking account of these gradient direction and amount, also the curvatures. Okay, so the field could be anything, doesn't really need to be curvature or gradient or anything. It could be any vector field you create. For example, it could be a vector field coming from like the noise function. It might need to be aligned with the faces, so I might need to calculate the cross section, the cross product between the normal and the average field. Then do the cross section again between this one and the normal. And let's try to visualize that. See how it looks like. Okay. That looks a bit too big. Okay. So let's try to create some interesting flow. Let's give some shift. Okay, it's not really changing its direction. That is because this is only on positive direction, so need to do something like that. Okay, gives you much interesting result. So based on those flow, let's see if it can give you a flow based on those flows. And color indicates the strength of this flow. But in this case, I might be okay using just a normalized scale. Over here. Just to see the flow itself. Okay, the size doesn't really matter anymore, meaning you could use the same minimum and maximum scale here to see the effect. There you go. Comparing these mesh together with the flow itself, you could see that the mesh is, you could see the anisotropic mesh is really working. You could see these alignments. The vector field is aligned with these triangle meshes. Yeah, so I think it's working. Yep. So that's it. That's how I did it. I'm not sure how practically this could be usable, but just wanted to show some approach. It could be useful for something other than anisotropic remeshing. Using Vellum as a solver, nonlinear solver, might be an interesting thing to approach in terms of the problem like these, especially for geometric problems. I think it's pretty useful. So that's it. You could feed in any kind of vector field, get the result like these. Okay, so let me know if you have any questions. If not, I think it's time for me to go to bed. Sorry for being I think most of the time I've been debugging, so sorry for that, but that happens. I have a question. Junichiro, what Mac machine are you using? I'm using MacBook Pro M1 Max with 64GB of memory RAM. So it's pretty high spec, I guess. I don't plan to buy M2 though, it's too expensive. In terms of modeling, I'm okay using either Mac or Windows, but in terms of rendering, I guess I still need to use Windows instead of Mac, because GPU is not that great on Mac. Alright, well, thank you very much everybody for joining, even after a month of absence. I will try to continue doing the live stream as well as other videos on algorithmic designs. Given that you use all this Vex code, do you do any GLSL on other shader languages? I sometimes do WebGL. Don't write that much code there, but I do a little bit of WebGL as well as some Unity shader languages. But casually. Okay, let me bring all the parameters in one place and finish this live. I'll keep this as a reference here. Gonna name all these edge links. Do you guys have any questions in terms of the process? If so, let me know. Or if you have any idea how this could be used, that would also be great, because I'm not really sure how I can use this. I just try this out, try this idea that I thought it could work, and seems it did, so I just wanted to share it with you. But in terms of how I can use this in practice, I am not sure. So the Caltech paper referenced in the link above gives example of how this actually can be implemented. Nice. Actually, I don't see any link in the chat. Maybe YouTube is deleting the link from the chat. Do you know the name of the paper? If you could paste the name of the paper, I could search for it. Caltech. Maybe it's this one. Looks like it's using vector field. Nice. Gotta look into it. This is really nice. Ah. Clean. Ooh. Just to have these kind of lines is also nice, eh? Cool. Yep, thank you for the reference. I will definitely look into this. Okay, let me clean this up a little bit. Oops, where was I? So this is the input. And this is where I calculate the vector field, creating the vector field. And this is where I'm creating all the edges, or actually this should go here, and this should go here. This is the simulation part. Okay, and then these are the remeshing back into the original geometry. So how do we call that? Defrost? I don't know. And you get the final result. Now let's also create a null node, have all the parameters you could control with the setup. And I also want to delete the parameter from this, which I'm not using anymore. Okay. You always try to do everything in Vex, if it's possible. Yes, because it's multi-threaded, it's fast. But sometimes it's pretty hard, especially if you want to do like large number of matrix calculations. I do need to use Python those cases. But for the geometry processing, especially in Houdini, if it's possible, I would love to use Vex because it's easy to use. It's pretty low level, fast in processing, all the good stuff here, and most of the geometry operation could be done in linear algebra, so Vex is good enough. But not always. I mean, if you need to interact with external files or need to use some libraries which has some rich functions, I do also use Python as well. Only if I can do in Vex, I'll choose that. If not, it's not really limited. Have you ever tried simulation stuff? DOPS? I'm not really good at DOPS, like fluid simulations or anything. I did do the basics. I think I know the basics, but I don't know the advanced stuff about the DOPS. One reason is because my PC is too low spec. Doesn't run simulations fast. And another reason is there's too many parameters that I don't know what it's doing. So feel more comfortable if I just make the solver myself, even though the function is limited. And I am not on the VFX or gaming field. I'm more in the architectural field, just making geometries, static geometries, so don't have much chance to use simulations myself. Have you ever considered a series like your Vex for algorithmic design, but with Python and what you can do with it in Houdini, or like the videos like in that in general, analyze data with it? That sounds really interesting. Yes. I would love that kind of idea, yes. If anybody is interested, of course. I myself found it really interesting. Your Vex video helped me a lot to understand and learn Vex. Thank you for saying that. It motivates me a lot. P stands for, what was it? Okay, power. I don't know if I need this since I have this curve, so I'll just give a ramp. Minimum scale, maximum scale, set the range, I don't know, maybe 200. Right. Okay, what else? I have I don't have any parameters here. I think I could set the parameters for how many iterations it will take to calculate. So this one here. All right, and this doesn't do. Okay, the final remeshing value. Anything else? Nope. I guess that's it. Okay, so everything is in one place to control the shape. Let's set the simulation iteration to 10. Gives you a result faster. Try to change the splines and see if I get any differences. This. Maybe. I'm not sure. Change this to curvature. And see if I could see some differences. Changing the curve. I'm not sure if I'm seeing the differences here. Wait, I think I'm not seeing the differences here. Is this being used? That is because minimum scale, maximum scale is the same. Okay, of course. There you go. Okay, I do see differences now. Nice. Nice. Okay, good to know. Okay. You mentioned you're not in games, but have you actually considered it as an option, or are you more passionate about staying in the architectural field? Well, I love playing games. I do love to work in gaming field if I have any chance, for sure. Yeah, I mean, I do use Unity myself to create some interaction stuff for work. I did some small games myself as well, so yeah, pretty sure interested. Just need an opportunity, I guess. How often do you use VOPs? VOPs and Vex similar. I saw people say you can do noise and stuff in VOPs better. I don't do VOPs myself. I know I used to use that previously, but I stopped using it because I became more fluent in Vex and I can write faster in Vex. But pretty much you can do same things both in Vex and VOPs. And as you said, in VOP the noise option is more graphically easy to control rather than Vex, because all the noise types are packed in one node in VOP, but each noise type is being used as a different functions in Vex, so you have to know each functions, how it operates for each functions if you are using Vex, so it's a bit hard to prototype compared to VOP, I guess. If you don't know the functions, then you won't be able to use it. I guess that's the problem with the Vex. But once you know, it's much faster to implement, so I would choose Vex, I guess. And there are some functions missing in VOPs, just a few, but which only available in Vex, I think. Used to be. I'm not sure right now if that's the case still, but for example, the function like SVD decomposition, like this one, I think I couldn't find this in VOP. So yeah, these kind of stuff. I mean, this is not a daily thing to use for, but sometimes these functions could be really useful for some cases. So for those reasons, I guess I would prefer Vex myself. But everything I did here today, I think you could also do that in VOP. Saying that you are interested in potential games, would you mind if I message about it? A tech artist using Houdini learning from games might be able. Definitely, yes. I would love that. Yes, if any information is glad to have. I'm using Twitter, so if you could send me a message there as a direct message, that would be great. Okay, I think everything is set, and all the things can be changed via these parameters. So that's pretty much it for today. Thanks for joining. Hopefully you found something interesting here. The things that I did was a bit not the casual thing to do, maybe not so much useful, but week to week I'm gonna come up with something interesting in many directions, sometimes entertaining, sometimes funny, sometimes useful, maybe. So hopefully you'll enjoy it. Okay, that's it. Thank you for joining the live. I'm going to change the color to something a bit more nice. So I'm going to change this to HSV to RGB to make it like a pastel color. Oop, other way around. RGB to there you go. Bit nicer. Okay. Without the edges. More like a stained glass like effect. Okay, that's it for today. Hopefully I'll be able to do some live next week as well. Might going to be really casual ones for next week. Okay, that's it. Well, thank you for saying that, Hex. Really appreciate it. I know that the way I explain is not really instructable, but I'll try to train myself to explain it in short time. Try to implement it in short time. Well, thank you. Okay. You should do something growth related. Yeah, I love growth related stuff as well. Yeah, let's try to do that kind of stuff. Your videos have really helped me. Other colleagues I work with. Oh, thanks for saying that. Really appreciate that. Knowing that things I do have helped somebody is really great to know. Yep. A big thanks from Japan. Well, then I guess it's time to go to bed. Good night, everybody, and hope you have a good day. Currently it's 3 a.m. in Japan, so bit time. Thank you.